Why is it not going? Come on, Zoom. All right, we're ready. So, like I was saying, I needed you to have this completed. I'm not going through all of it. There are a few that I want to talk about. So we had done the first city together. We had done Denver together and found out that Denver was 2,500 kilometers away. I noticed a huge amount of people screwing up Tampa's location. So Tampa's P wave gets there at 2:34:30. And its S wave gets there at 2:36 and 0 seconds. Now, I know what went wrong is a whole lot of people just tried to do the math in their head, and they're like, oh, 36 minus 4 is 2, and 30 minus 0 is 30. But when you write this out and you do 2:36 minus 2:34:30, and when you actually physically write it out, you realize you have to borrow from here, change that to a 35. This changes to a 60. So 60 minus 30 is 30. So that you didn't screw that part up, but now here, that's 1:30. So that's just a minute and 30 seconds, not 2 minutes and 30 seconds. And that's why I always say, guys, don't trust your head. Write it down, do the math. It's not going to kill you. It took me an extra 10 seconds to do the math. Well, maybe a little longer because I can't do anything because of my hand, but whatever. So now that we have that and you put that on the reference table, you would have gotten Tampa to be 800 kilometers away. And Chicago is 1,200 kilometers away. So again, you guys need to submit your homework so I know what's going on. If you guys got this all wrong, I would have spent some more time going over it, but this is what we got. Now, the reason I'm just giving you these answers is because we need these. So what we're doing today would have been kind of putting this all together. So we know now from what we did yesterday that the earthquake is 2,500 miles from Denver. 800 from Tampa, and 1,200 kilometers from Chicago. So now the next thing the Regents is going to make you do is say, okay, then where is that earthquake? And what we do is we take this information and put it on a map. Sorry, I'd already done that one, so I got to do a different one. Gotta grab a blank one here somewhere. Shoot, where did I put all the blank ones? There we go. So we need to put that information on this map. So what we know is here's Denver, and according to our math, the Denver is 2,500 kilometers away from the epicenter. What that does not, and we talked about this before break, that means the earthquake is either 2,500 kilometers this way, or 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 basically a circle around Denver that has a radius of 2,500. So we're going to actually have to draw that. So for drawing circles, we use compasses. This is probably a compass you are familiar with. This is not the one we're going to be using, but you can see there's a sharp pointy end and then a pencil. You use the scale, open up the compass, and here's how a normal compass would work. You pin it down and you can draw yourself. Oh, if you had two hands, oh, okay. If you had two hands, I can't do it, but in theory, maybe I can use my left hand. Not real well. Oh boy. Left hands don't work for me, but you can draw yourself a circle with this pointy compass. Luckily for me, we don't use those because, well, you guys, I've learned in however many years I've been teaching, I don't trust 10th graders with sharp pointy objects. Sorry to stereotype you. So we use these safety compasses. They work very similar. This is a bullseye. That's the equivalent of, sorry about my injury. That's the equivalent of the sharp pointy end. And here's where your pen or pencil will go. So what we do is, since we know the earthquake is 2,500 kilometers from Denver, on the scale, we find 2,500. So here's 1,200, 3,000. So halfway in between is 1,000 or 2,500. So we're going to open our compass to 2,500. If we were using one of these sharp pointy ones, we would just pull them apart so they were that big. But with the safety compass, it's actually a little bit easier. So we put this end, which is called the bullseye, and you can probably see why it's called a bullseye. So there, oh, maybe I can't. You can see if I, yeah, you can't really. So there's a circle and a dot in the center, kind of like the target symbol. So there's a circle with a circle on the inside. So that's the bullseye. We line that up with the 0, and I do this 90-degree angle here. Put that on the 0. This knobby thing moves so it can unscrew and move this end. So I want to move that so it points to 2,500. So you'll notice there's 2 sets of holes. So you can either use this one or slide it back and use this one. Honestly, it doesn't matter which one you use as long as you pay attention to which one you're using. So right now I'm measuring with the outside one. So I'm going to tighten that down on 2,500. So it's there. And I'm using the outside holes. Remember, it's good to remember I'm using the outside hole. So I put the bullseye over Denver. Move this away a little bit. Put my pen, again, I was using the outside hole. Hold down the bullseye, drag my pen around. Sorry, I'll come back. And you get, minus this area where I missed because I don't have 2 hands, you get a nice circle around Denver. So anywhere on this circle is where the earthquake is occurring. All of the places on the circle are 2,500 kilometers from Denver. So it narrows it down, but it doesn't tell us exactly where the earthquake is. So that's why we need the other 3 cities. So we also know that it's 800 kilometers from Tampa. So I'm going to do the same thing. Come back here. I'm going to go to 800. So 500, 600, 700, 800. Point my, this time I can only use the inside circle. See, the outside circle doesn't get that small. So tighten it down. Oh, I'm sorry, you guys can't see that. So here's what I was doing. I was just pointing to the 800. Again, can't use the outside the hole because it doesn't get that small. So I go to just 800. This is going to be for Tampa, so I got to switch cities. Put my bullseye over Tampa, put my pen in the smaller hole because that's the one I use to measure. Ugh, everything's in my way. And there you go. We have a circle. I'm just going to attach this freehand. There you go. So everywhere in the big circle is 2,500 miles or kilometers from Denver. Everywhere in the small circle is 800 miles or kilometers, I'm sorry, from Tampa. These 2 spots right here are both 800 from Tampa and 2,500 from Denver. So those are the 2 places the earthquake could be happening. Now we'll add in our last bit of data, and that was for Chicago. Chicago is 1,200 kilometers away. So I open up my compass to 1,200, plop that over Chicago. Oh, and I can't remember if I use the bigger or smaller. So I use the inside hole, put that on Chicago, and I'm going to draw myself a circle. And crud, something went wrong, but that's okay. So there is nowhere where all 3 of my circles are touching perfectly. 2 are touching here, 2 are touching here, 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 and here. So there's nowhere where all 3 are touching perfectly. And this could be a problem, except for, remember how I always give you, I say, well, you could be 100 miles off or 100 or 200 kilometers off, and it's okay in the math. But here, when you try and put them onto the page, sometimes it doesn't come out perfect. What you have to realize is right in this general area right here, all 3 circles are trying to touch. So even though they're not touching perfectly, this will still get you full credit because you were really only off by 100 or 200 kilometers. And it's, again, not that big a deal, but once you put that on a map, it turns out to be quite a big difference. So as long as you can see that all 3 are trying to touch in this general area, that's where you say the earthquake is happening. All right, so that's literally would have been the end of the chapter right there. We need to practice some more though. The reason why I say you need to practice is up until now, all the questions you have done in this chapter have been questions I've written. And I mean, not to say I'm not good at this, but my questions are easier than the Regents questions. You guys have been doing Regents tests lately, and or for the couple of years here, and you know that I always say the Regents people are mean, nasty people, and it's like they try to trick you. And the same is true for the earthquakes. So I assigned you this homework assignment. It's really a classwork assignment. And I want to do it, and I wanted to do it together, but since my room is empty, I'll have to do it with you guys on Zoom. Or at least I don't want to do it together. I want you to do it so you can ask me questions. The Regents people are jerks. And they're even in this first question, they're messing with our heads because up until now, we've always used the keywords arrival and travel. But let's read this first one together. How long would it take for the first S wave to arrive at a seismic station 4,000 kilometers away? Now here they're messing with us. How long would it take to arrive at a seismic station 4,000 kilometers away? This is not the same as when we say, what time will they arrive? Or what is the arrival time difference? By saying how long it takes to arrive, if I asked you, hey guys, how long does it take you to arrive at school? I mean, for me, my commute, my drive to school, it takes me 45 minutes to arrive at school. That's the same as saying, hey, Mrs. Ritz, what is your travel time to school? I'm traveling 45 minutes to school. So now they're changing it up. And by saying how long does it take to arrive is the same as saying, what is the travel time? And you guys are experts on figuring out travel time. So there you want to know how long does it take to arrive at a seismic station 4,000 kilometers away? 4,000 kilometers, S wave, read over, and you've got the answer to number 1. So what I want to do, you guys still have 25, 30 minutes. You have like a half an hour. I want you to work on this now. Like you were sitting in my classroom working on this. I'm going to leave you on Zoom. And I'm going to leave Zoom open. So if you have any questions, you can ask me now is the time to do this. If you don't want to ask questions and you want to just turn it in the way it is, you are welcome to leave. But I would like you to stay on Zoom and ask me any questions you have. Just like you would ask me if you were sitting in front of me and you're like, I can't do number 6, I would help you. So let's do that now. This is on Teams. So open it up. You're going to be doing your answers on a separate sheet of paper. And that's it. So let me know if you have any questions.